Hi, welcome to this session 3.1, where we're going to use more variables and attributes in order to better control the model. In this particular example, we're going to use a very simple model, which is composed by one part A1 that creates parts A2, A3, A4, and A5. That's why the last one are passive parts. We have 5 buffers, 4 single machines where the passive part are created, one assemble machine that joins the 4 last parts, A2, A3, A4, and A5, and creates A5. Then 3 conveyors that connect the section between machines and the assemble machine. So the layout is very simple. We can see here that A1 arrives to B1, then M1 send to the most empty conveyor B2, B3, and B4, A1, and then machines M2, M3, and M4 create A2, A3, and A4, then send that to those 3 conveyors, and M5, considering the sequence of 2 A2, 3 A3, and 1 A4, creates A5, which is sent to B5. We can see in those boxes that there are all the cycle times as a CT, and then some advices about how different details should be. For instance, the index of the conveyors, where to push part and which part are created. Also, we can see that once the model is created, we should be able to see something like this. So remember that you can go to view and see the layout. Here is how the M1 logic works. So basically in the output rule, we use that function, which is list part B2, B3, and B4, which is saying that whenever the part is at M1, it's going to look for which is the most busy, which is the less busy buffer to send the part. Then M2, M3, and M4 follows the same logic, so which means that they will pull part from B2, M3 from B3, and M4 from B4. The cycle times, of course, will change as we know from the previous layout. Now here, this is something very important. Here in action and finish is where we change the different parts. So we use the function change all to A2. We change the description, and also we change the icon. So we're going to, in M2, we create A2, that's A2, and then the icon that corresponds. M3 will do A2, and then M4 will do A4. And then the M2 is going to push to C1, M3 is going to push to C2, and M4 is going to push to C3. Then finally, M5 is an assemble machine, as you can see here, and then we use this function sequence where I'm saying that I'm going to get 2 A2 out of C1, 3 A3 out of C2, and then 1 A4 out of C3. This is a very simple function. Of course, you can just replicate it and then you can use it. And then later on, of course, you need to answer a few questions. After this, we're going to add a few variables, so then we can understand how we can measure different things. So we're going to create variables and attributes. Basically, the attributes are going to be used to capture the time when every part arrives. So then we're going to collect how much time, for instance, every part is spent in different buffers. So those are the functions. So as we can see here, whenever a part arrives to B2, we assign that to an attribute value, which is basically the attribute A1 time in. So we have A1, A2, and A3. And then once they go out, they do the difference. So then we have this function time, which is the time of the simulation, minus the attribute time when they arrive. And that is basically what happens. Then with this, we should be able really to connect with the model, and then we should see those results. Now, interestingly though, you can see that the name of the attribute can be the same for everybody. So this is just a reference name, so it may get confused that is because A1 is A1 for everybody, but basically the attribute is just a place where you save a value, and is as a name can be the same, but the values will be different because every value is assigned for every part. So, but let's do the model, so which is something more important. So I'm going to minimize this. Let me see. I'm going to minimize this part. I'm going to do it like this, right? More or less, so that I can see it. This is my witness model. So I'm going to create a totally new model. I'm going to look at view design elements. So this is the basic elements, as you know. I'm going to minimize this to make it quicker. Maybe, let me see, just to adjust to my screen. So this. Okay, so this is here. Okay, so I'm going to view the interact tree since I need it at some point. Now, and also I'm going to do the model assistance because later we need to use these distributions. So basically I have A1, B1, M2, B2, 3 and 4, M2, M3 and 4, and then I have C1, C2, C3, M5 and B5. So the first thing I need to do is to, as you know, I need to create the model. So I'm going to make this bigger, like 120. So I have 5 parts. So basically I'm going to do this, create like this. So this is like this, for instance. This is something interesting. Look, so if I right click on this and I create A1, then I'm going to create A2, for instance, A2. Then, for instance, I can clone this, for instance. I have those 2 parts. Then I'm going to clone them. So I would click on clone, then I click here, and then I click here. So I immediately create quickly more parts, A3 and A4. And actually, I'm going to clone this one and here, and then A5 is created. Now, which is interesting is that also you can align this, a little bit. I'm going to make this with the arrow. I'm going to make this. Then I can select this, and I'm going to align this to the left so that all of them are aligned. I'm going to do the same with this one. I'm going to align them to the left, and that's it. I'm going to do this, more or less, so then we can see they are correct. So of course, it's difficult to align the model, so that's why those buttons are very useful, to be honest. I'm going to make this like this. So then I can align this from those 2 to the center, let's say to the bottom, or can be to the top, like that. So I can try to make sure that all of them are aligned to, in the same way. So that's basically it. To the top. This is also aligned them to the top. Let's see if there's an effect. Yeah. So this is more or less like this. So this is every part here. So just want to make this more organized. So A1, we see that is the green part, as you know. So green is going to be here, right? Then we have A2 is the yellow. So I'm going to put that immediately, the yellow. Then A3 is the red one. Then A4 is the purple one. There you go. And A5 is the blue one. So I'm going to create the buffer. So this is B1 here. So in the same way, I'm going to create B1. So I'm going to make it this. And I'm going to clone this. Create B2. I'm going to clone those 2 just to make this quicker. So here we do B2, which is here more or less based on the model. And then I'm going to do M1, which is this one. Sorry, this one. So this one is M1. So in the same way, I can clone this to create the other machines. To clone this one here. So here, I'm going to clone this one here. I'm going to clone this one here. That's it, basically. Then I have other ones, which is M5. So I'm going to I'm going to put that more or less to the left, just creating a quick model basically. So that's it. Oop, this is so this is something like this. Okay. So then I'm going to create the conveyors. So I'll do the transport. Here's the conveyor. So this is the conveyor one. So this is conveyor one. So I'm going to put C1 to make it a little bit shorter. Doesn't matter really because it's just a graphical thing. So I'm going to make it like this. Yep. So you need to make sure that all of them are the same. So in terms of characteristic, I'm going to clone to C2 here. I'm going to clone to C3. There you go. Then I'm going to create M5. I'm going to clone this. You see that immediately M5 is created. And then I'm going to clone this, which is B5. Right, this is basically also, I'm setting up the model quite quickly. So now what I know is that MA1 is being pushed to B1. So this is what I do. So M2 pulls from B2. That's what I do. Then what I know is that M2 pulls from B2. That M3 pulls from B3. That M4 pulls from B4. That then M2 pulls to C1. M3 push to C2. M4 push to C3. Then M5 push to B5. Now, the other function that, and then of course, this one we need a selection, and here is we have all the changes. So basically what happened here, if we look at the cycle time, just to be quick, M1 says that it's using a uniform 0.51, no, 1. Then M2 is using a triangle 5, 9, 10. Then this one is using a Poisson 10. And there's something wrong. Sorry, wrong. Poisson 10. And then this is a normal 10 2. M5 just to be here, be clear. A5, as you see, is an assemble machine, so I'm going to say that immediately. Assemble, and the cycle time is 6. This is what we do. The index for C1, we said that the length is 30, and the index is 2, sorry. C2 is 40, and the index is 1. And then C3, the length is 10, and the index is 10. Okay, and okay, this is all what we can do. Okay, and now I'm going to do the M2 function, the M1 function. So here we can see that in the function of M2, M1 in output rule, we say here that the output rule here is the function list part B2, B2, B3, and B4, which means that whatever B2, B3 is more empty or with less part is going to push part to there. Then what we know here is that if we move forward, is that every machine will change different parts. So for instance, we see from here, from the model, that we have A2, A3, and A4. So A2, A3, and A4. So basically what we do once a part get there, once they finalize the sequence, the process. So here we need to add in action and finish. we say that change all to A2 in this case. We change also the description to A2, and also we change the icon, which is equals to 135. In case you don't know which icon is, we can just, for instance, right click over this. We click on update graphic, and here says is the icon 134, where the green is 132. So now the next one is 134. So this one we just need to copy paste this text basically, just to make this quicker. So here we just click here. Here we change to A3. We change to A3, and then we know that the icon is 134. So remember, 134, 134, and the purple is 133. So here we do the same. So we do A4, A4, and the icon is 133. Correct? So now we have that, and now here, basically, what we're going to do is that we need to have a sequence. So in the sequence, as you can see here, in the output, in the input rule, basically, we have a sequence. So here in M5, we say that we have 2, 3, which is 5, plus 1 is 6. So the minimum quantity is going to be 6. If you don't do that, it's not going to make the sequence possible. So you need to know the total number of parts, and then you say the order. So in this case, we do sequence slash weight, and then we say we need A2 out of C1, out of C1. Basically, let's just leave it like that, and that we put this symbol 2. Then I'm going to just copy paste this, so then it's replicated to do it quicker. So that's it. Yeah, reset this. Then we have A3 out of C2. For this one, we need 3. And then, for instance, in this case, out of C4, C3, sorry, we need A4, which was created. It's there actually. That's why we change the description, so that it's not just the icon, it's also the part itself. So then we validate this, and then it's validated. Now look that here in this example says up front, and then I didn't include that. I'm going to click on OK now, and I'm going to see the sequence now again. Now witness automatically add that it assumed that because of the logic is saying that, well, if the part goes from the left to the right and the front is the right, so I'm going to take part from the right. So you can say things differently, like you want to change things from the beginning. You know, you can set different rules. But witness says if nothing else is saying about it, so probably we just do that. So then I'm going to save this model. By the way, this is very important. Yeah. So I'm going to, let's say, in the lab session 3, I'm going to create this lab 3.1 version A. Now I'm going to see if the logic is what I really want to see. So I go to view, element flow. This is what I got. So I'm going to also to view, let's say, I'm going to maximize this. So now we're going to simulate the model. I'm going to put this like this. So okay, I put the arrival time. So we got that one. So it goes there, goes there. So it's going to process everything. The part were created. I'm going to make this look quicker. It take longer. We can see how different parts are sent to different places, and then we know that we have to see the sequence. And the sequence is very important because if for some reason the sequence cannot be met, what happens is that the model will fail. So that's why it's important for us to make sure that at least we can get those parts. So go those 3. We need to still wait for the purples because it's quite slow in that sense. So whenever it's going to arrive, but you see that M5, because has 2 from C1, 3 from C2, it still is waiting for the part from C3, right? So which means that it's waiting for that sequence before you can create the next part. So the model is working. Now I need to, okay, this is one part. Now we need to make sure that from M5 we can create A5. So I'm going to minimize this, basically. So I'm going to just rewind this. So here, whenever we change here, so we use the same rule basically. We know that the icon from this one, if we take graphics, this is 131. So here, once we do all this, right, in action and finish, we just click on, oh, sorry, it was not that one. I'm going to make it again. So from M4, we have this. So in action and finish, we say change all to A5. This is 131. This is A5. So it's 131, I think. Graphic 131. So then we make this quicker. So we get the 2 from there, 3 from C2, and then we just need to wait for A4 to arrive till the A5 is created. They created, and then we have A5 created. So we have the sequence, which is working. So I hope that you have enjoyed this part. It's very interesting. So the next video is going to show you how to create these variables on this model. Thank you.